All right, hello my little programmers. Welcome back to another Python tutorial. Today, we're diving into the world of string manipulation. So you might be wondering, why focus an entire video on strings? Well, in our digital world, text is everywhere, from tweets and emails to product reviews and web content. Being adept at manipulating and analyzing text data is a foundational skill for any Python programmer. Whether you're cleaning data for a machine learning project, building the next big app, or simply automating everyday tasks, string manipulation is often found to be at the core. As you advance in your Python journey, you'll find that many complex tasks often start with the simple string operations. So let's jump right into it. First, let's talk about concatenation. Concatenation is when we combine pieces of strings together in order to form a longer string. This is a pretty common task, especially when manipulating the print function to customize our output. We can concatenate strings by simply adding them to one another using the plus sign. Here, I'll concatenate two string variables together using the plus sign in order to create one longer string. Keep in mind that we will need to build in spacing into our string variables so that our final message is not bunched together. Another thing to keep in mind is that Python can only concatenate string variables together. Therefore, if you have numeric variables that you would like to integrate into a string sequence, these will first need to be converted into string variables using the stir function. We can demonstrate this by building on an example from a previous video where we interacted with the user about their favorite baseball player. In this video, we utilized the input function to ask for their favorite player's name and stored it in the player variable. We can now inquire about the number of at-bats that the player had by carefully concatenating our strings together, incorporating proper spacing. We can now do the same with hits. Finally, we'll convert these inputs into floats, divide them, and round to 3 digits. In order to print this in a single string, we simply need to concatenate our strings together, making sure to convert batting average into a string variable. When we print this, we see that we have tailored a nice, clean response to our user. I'm now going to review some of the common functions and methods that we use on string data. First, let's clarify a few terms. In Python and many other programming languages, all data, numbers, strings, lists, and more, are considered objects. Each of these objects has its own methods and functions that are specific to its data type. Let's clarify this with an example. First, we need a string. Let's assume we're working with a promotional tweet created by a fictional company called TechCo. I'll store this tweet in a variable. Now, let's start looking at some string methods. You can recognize a method based on the dot notation you see here. In this example, this method takes our string and converts it to all uppercase letters. Importantly, this method did not overwrite the original object. If we print our tweet string again, we see that the original version is preserved. In order to overwrite the variable, we'll need to store our manipulated string back in the original variable. I've included this syntax as a comment. However, be careful with this. Once this bit of memory is overwritten, it cannot be recovered. As such, it is more common to store a manipulated string in a new variable. In this example, we've created a new version of our string that is all lowercase letters and saved it in a new variable to avoid losing any data. Once again, these are methods that are directly tied to string objects. This can be clearly seen based on the dot formation, which is different from a function as displayed here. In this example, TechCo might choose to use the len function to determine if the tweet meets Twitter's 280 character limit. Further, they can store the length of this string in a variable called tweet length and use this variable to create a Boolean variable determining if the proposed tweet is valid on Twitter. Another method that TechCo may consider is the strip method, which removes the white space or extra spaces from the beginning and the end of the string. After examining our stripped variable, we can see that this is an improved version of our tweet. TechCo might now decide to go ahead and store this string in the original tweet variable, overwriting the previous data we had in this variable. TechCo might also decide to create a list of words that can be incorporated into a larger analysis or an extraction of hashtags. We'll talk about lists in a future video. For now, let's look at the syntax for creating this list of words, which involves using the split method. Here, we see that an array of words is returned. Store this away in your memory, as Python lists are a foundation of most data science libraries. Finally, I should mention that most methods and functions have arguments that can be passed inside. An argument is simply syntax that specifies exactly how you want the method to operate. I'll demonstrate this with the count method, which TechCo might use to count the number of hashtags included in the tweet. This is an example of a method that requires at least one argument. If we fail to include the argument, we'll get an error because Python doesn't know what exactly it should be counting. Therefore, we're going to include a hashtag string as an argument. This is instructing Python to count the number of times that a hashtag has appeared in the string. Another method that requires passing in an argument is the find method, which will return the index at which a substring may appear in the object. This is a feature that TechCo might choose to use to determine if their website is appearing early enough in their promotional tweet. So speaking of a string's index, this is actually a crucial topic in Python that will only become more important as we begin delving into data analysis in a later video. In this context, an index refers to the numeric position that a target data point can be found within a sequence, in this case, a string. This is analogous to a row of boxes, where each box contains a letter from a string. Indexing allows you to pinpoint exactly which box you want to open to view and manipulate its content. Now, a very polarizing and confusing issue with Python is that indexing is zero-based. That is, the first character in a sequence is considered the 0th character. And you might be wondering why. Well, there is some historical and practical reasoning behind this decision. Historically, early programming languages used indexing to reference movement from a starting position, so the first item in a sequence had 0 movement. More practically, there are a few mathematical advantages to zero-based indexing, as some argue that it simplifies mathematical calculations, such as when you're determining the length of a range or an offset, because we're allowing for more straightforward subtraction without additional adjustments. However, most, such as myself, simply find this to be an annoying Python quirk. We call for an index in Python by including the desired index as an argument within square brackets. I'll demonstrate this using our tweet string. Here, you can see that our first character is stored within the 0th index. Because of this zero-based indexing, our 6th character is indexed at the number 5. Python also conveniently offers the option to count backwards using negative indexing. Here, our last index is stored at -1, our second to last at -2, and so forth. We can also slice strings. String slicing is when we select a substring range from within our object. The syntax for this involves utilizing a colon to target the substring. However, here's another potentially confusing quirk when it comes to Python indexing. When we're slicing, the slice is inclusive of the starting position, but exclusive of the ending position. take a look at this example. If we want to select the first 10 characters, we start at 0 and we end at 10. This slice will include the 0th index, which is the first character, but exclude the 10th index, which is the 11th character. Similarly, if I wanted to select a random substring, such as the 5th through the 10th characters, I would need to call on indexes 4 and 10. As a shortcut, we can omit the index on either side of the colon, and Python will simply run the slice from the beginning or to the end of the string. Here, I can slice from the beginning of the string, but omit the 0 index. Python knows to start from 0. I can also do this in the other direction, slicing from the 11th character to the end of the tweet. We can also slice strings indexing from the end of the sequence. For instance, here I am requesting the final 10 characters of the sequence. And we can also engage in what is called step slicing, wherein we request a pattern of characters from within our string. We can do this by adding another colon and specifying at what step we want our substring to be conducted. For example, here I am asking Python to provide me with a substring that is the first 20 characters of the tweet, but I'm specifying that I only want every other character. In other words, I'm setting the step to 2. Finally, we can combine the reverse slicing and the step slicing concepts and manipulate our string to put it in reverse. In other words, we can request a full slice of the string by leaving both sides of our colon empty. Then we could set our step to -1. This is asking Python to step backwards from the last character in our string, one at a time. Okay, let's look at how TechCo might combine string slicing with some of the methods we discussed earlier to perform a practical task. Let's say that TechCo wanted to extract the full hashtag out of their string. In other words, they wanted to find a way to automate the task of pulling out the hashtag sale day from their tweet without knowing the exact string in advance. To be clear, we want to write code that can extract hashtag sale day from our tweet without knowing the specific text sale day. The first thing we need to do is establish a few rules for identifying the beginning and the ending of our target substring. We know that our target is going to begin with the hashtag symbol. So let's use the find method to store this character in a variable called hashtag start. Next, we can safely assume that our hashtag will end the next time Python sees a space after the hashtag. Therefore, let's use the find method again to store this position in a variable called hashtag end. Thing that I did not mention earlier is that the find method accepts more than one argument. In fact, many of the methods and functions that we have covered do as well. I encourage you to explore for yourselves the various argumentation of common Python methods and functions. Covering them all would not be feasible for a bootcamp style tutorial. With that said, the second argument for the find method is optional, and it allows for us to tell Python from which character to begin searching. Here, we'll use our hashtag start variable as our second argument. This is instructing Python to not search for spaces until after it finds a hashtag character. Finally, let's use these two positions as indexes for our tweet string. We'll use our square brackets and call upon our hashtag start and hashtag end variables as our string slice. We'll store this in a variable called hashtag. When we print this variable, we see that we were able to successfully extract the hashtag from our tweet. In the future, we'll learn how to scale this concept by writing a function that can iterate through a series of tweets, extracting all of the hashtags and storing this in a data frame. Speaking of scaling some of these methods, one last concept involving string manipulation that I would like to cover is called f-strings. F-strings are used to create a template that can be adapted to changes in parameters. For example, assume that the company has various sales events, discounts, and product types that it promotes using the same tweet template. It would be helpful to use a single string for the tweet variable, but swap out the events, discounts, and products in an automated fashion. We can do this pretty simply using f-strings. Let's first create a few variables. I'll create string variables where I store the sale event, discount, and product type. Next, we'll create our tweet template. We'll signal to Python that we are using f-strings by starting with the character f before we open our quotations and start our string. Next, we'll insert our template. However, importantly, we'll put placeholders for each of our variables using squiggly brackets. When we print this, we see that the string template was adapted based on the parameters we had in mind. We can do something similar to generate a report based on the engagement data that our tweet generated. Let's create variables representing the number of likes, retweets, and replies created by our tweet. We can now create a simple report template that depicts the engagement data for this tweet and repeat this task quickly across all of our tweets for the sake of comparison. Here, we'll use what's called an escape sequence. An escape sequence is denoted by a / and the letter N. It represents a new line character, which means it's used to indicate the end of one line of text and the beginning of a new one. This will instruct Python to print our report in a clean line-by-line format. Well, that about it for today's video. If you're able to stick with me through this full tutorial, you should be proud of yourself. String manipulation is admittedly a pretty dry and technical topic, but hopefully you take solace in the fact that these concepts will be incredibly valuable as we advance to more rigorous data science tasks. Learning string slicing in Python provides foundational knowledge on how to extract and manipulate segments of data. Soon, we'll be analyzing data sets in libraries such as pandas and NumPy, and similar slicing techniques are used to select, filter, and transform chunks of numerical data. More on that to come in future videos. I'll see you then.